Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Group Harms, Discrimination and Bias in AI Systems. Artificial intelligence systems have increasingly become integral to various aspects of society, from healthcare and law enforcement to finance and advertising. However, with this growing reliance on AI, there is an urgent need to address the potential harms these systems can inflict, particularly in terms of discrimination and bias. Discrimination and bias in AI systems manifest when these technologies perpetuate or even exacerbate existing societal inequalities, often unintentionally, due to the data they are trained on or the algorithms that govern their operations. One of the primary sources of bias in AI systems is the data used to train them. AI systems, particularly those based on machine learning, rely on vast amounts of data to learn and make decisions. If the training data contains biases, the AI system will likely replicate and even amplify these biases. For instance, if an AI system is trained on a dataset that reflects historical hiring practices favoring certain demographics over others, the system may recommend job applicants in a biased manner, thus reinforcing workplace discrimination. This phenomenon is not merely hypothetical. There have been real-world instances where AI systems have demonstrated biased behavior. In 2018, Amazon scrapped an AI recruiting tool after discovering it was biased against women, as it had been trained on resumes submitted over a 10-year period, predominantly from men. Another critical issue is that AI systems can inadvertently learn and perpetuate societal stereotypes. Word embeddings, a common technique in natural language processing, have been shown to capture and reflect gender and racial biases present in the training data. For example, Bolukbasi et al. Demonstrated that word embeddings trained on a large corpus of text associated the word man with computer programmer and woman with homemaker. This kind of bias in AI can have far-reaching implications, influencing everything from language translation services to search engine suggestions. Algorithmic bias can also arise from the design and implementation of AI systems. Developers' subjective choices, whether in selecting training data, defining objectives, or designing evaluation metrics, can introduce biases. For instance, facial recognition technologies have been found to have higher error rates for individuals with darker skin tones compared to those with lighter skin tones. This disparity is often due to the lack of diversity in the training datasets and the developers' oversight in ensuring the system's fairness across different demographic groups. Such biases can lead to serious consequences, such as misidentification and wrongful accusations, particularly in law enforcement contexts. Moreover, the deployment of biased AI systems can have significant societal impacts, particularly on marginalized and vulnerable groups. For example, predictive policing algorithms, which aim to forecast criminal activity based on historical crime data, have been criticized for disproportionately targeting minority communities. These systems can perpetuate a cycle of over-policing and criminalization of these communities, exacerbating existing social inequalities. Similarly, AI-driven credit scoring systems can systematically disadvantage certain demographic groups, leading to unequal access to financial services and perpetuating economic disparities. Addressing discrimination and bias in AI systems requires a multifaceted approach. One critical step is ensuring the diversity and representativeness of training data. This involves not only collecting data from diverse sources, but also continuously monitoring and updating datasets to capture changes in societal norms and behaviors. Additionally, employing techniques such as reweighting, resampling, and debiasing during the data pre-processing stage can help mitigate bias. Another important measure is the implementation of fairness-aware algorithms, which are designed to explicitly account for and mitigate biases. These algorithms can be programmed to ensure that their decisions do not disproportionately benefit or harm any particular group. Techniques such as fairness constraints and adversarial debiasing can be utilized to achieve this goal. Furthermore, it is essential to establish clear guidelines and standards for fairness in AI, including the development of robust evaluation metrics that can assess the fairness of AI systems across different contexts and demographic groups. Transparency and accountability are also crucial in addressing bias in AI. Developers and organizations must be transparent about the data sources, methodologies, and decision-making processes used in their AI systems. This transparency can be achieved through documentation practices such as model cards and datasheets for datasets, which provide detailed information about the data and model characteristics, including potential biases and limitations. Additionally, establishing accountability mechanisms, such as regular audits and impact assessments by independent third parties, can help ensure that AI systems are held to high ethical and fairness standards. Public and stakeholder engagement is another vital component in addressing AI bias. Involving a diverse range of stakeholders, including those from marginalized communities, in the development and deployment of AI systems can provide valuable insights into potential biases and their impacts. This collaborative approach can help ensure that AI systems are designed and implemented in a manner that is inclusive and equitable. Education and training are also essential in promoting awareness and understanding of AI bias among developers, policymakers, and the general public. Incorporating ethics and fairness in AI curricula and professional development programs can equip developers with the knowledge and skills needed to identify and address biases in their work. Policymakers, on the other hand, need to be informed about the potential risks and benefits of AI to create effective regulations and policies that promote fairness and accountability. Finally, fostering a culture of ethical AI development within organizations is crucial. This involves creating an environment where ethical considerations are prioritized and integrated into every stage of the AI development lifecycle. Encouraging a culture of ethical reflection and discussion, supported by organizational policies and incentives, can help ensure that AI systems are developed and deployed responsibly. In conclusion, while AI systems have the potential to bring about significant societal benefits, they also pose risks of discrimination and bias that must be carefully managed. Ensuring the fairness and equity of AI systems requires a comprehensive and multifaceted approach involving diverse and representative data, fairness-aware algorithms, transparency and accountability, stakeholder engagement, education and training, and a culture of ethical AI development. By addressing these challenges, we can harness the power of AI to create a more just and equitable society. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UExcel, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.